The Executive Director of SilverLining. We are a 6-year-old nonprofit organization focused on near-term climate risk. It's our real honor to partner with NYU Langone School of Health in looking at climate change and climate responses in the context of public health and in particular mortality from heat. And we know that we're looking at a future in which the risks are rising from climate change. And today we're going to talk about a particular kind of risk, a stark kind of risk, the mortality risk from extreme heat. Just reminding everyone, we've seen escalating extreme heat events in the past year or two. In 2023 alone, we had increased mortality from extreme heat in Arizona in the United States. We had an extreme heat event in India, including at an outdoor gathering in which there were a number of casualties from extreme heat. And so we know that in this particular case, climate risks are escalating public health and public safety issues. So from SilverLining, the way that we look at the problem fundamentally is the increased heat stress in the climate system. And the universe might not want me to talk about that too much to this group of refined scientists, so you all know it's there. And in particular, we've been concerned about the fact that under every scenario for emissions reduction, the warming in the system is projected to continue to rise. So we have the twofold problem that our projections of what that means in terms of climate impacts and mortality are not as strong as we need them to be, and that our portfolio of responses in that period to bend that curve faster if we need to, particularly to save human lives, is an issue. So I'm talking today about Project Heatwave. And Project Heatwave is an initiative that wants to bring together the various components all the way from individual patient level responses to extreme heat, through communities, through infrastructure, through population dynamics and responses, and all the way to the most large-scale responses in the climate system. And the goal is to be able to better project mortality from extreme heat all the way down to the population level, and to be able to study and develop responses all the way through that individual to global scale level. And in the context of that, at the global scale level, that includes looking at interventions to directly reduce heat in the climate system, namely what scientists have identified as the most promising areas for research, which is reflecting sunlight from particles and clouds in the atmosphere, or the release of long-wave radiation through cloud thinning. And so those techniques have been recommended for research. They've been recommended for international assessment. There's some increased urgency around looking at those things. And there's some increased understanding of significant gaps in the knowledge that we have and the research needs that we would need to address in order to fill them, and particularly related to gaps in our climate models that require both observations, substantially increased observations, and directed research on climate interventions to fill. So we in SilverLining have worked with some of the people in this room, and I thank you, over the years to help identify and detail a roadmap of the kinds of things that might be useful in the context of advancing the information that we need for robust scientific assessment and future decision-making on climate interventions. And today, we're really blessed to have panelists on both topics, extreme heat and what that means for patients, for populations, and how we might think about driving interdisciplinary assessment, how we might think about interdisciplinary research effort to rapidly increase our understanding of extreme heat mortality and responses to it. And at the same time, we have a very esteemed panel on the topic of climate intervention. And to walk us through all of this, we have a true expert on both extreme heat and climate intervention, journalist and author Jeff Goodell. Jeff Goodell wrote the New York Times bestselling book, The Heat Will Kill You First. That's his most recent book on the topic of extreme heat and climate change. One of many seriously good reads from Jeff if you're looking to walk through kind of the history of climate. And early on, in the way that I met him, he wrote a book called How to Cool the Planet. And he was among the first journalists to dive in on the topic of climate intervention. So it's my pleasure to introduce you to Jeff and have our first panel come up on stage. Jeff and panel, will you join us?
Great, I'm happy to be here to be part of this. I want to thank you, Kelly, for the introduction. I just want to say one thing really quickly about this is that I kind of came to this backwards. I wrote about, my most recent book was about heat, but before that I wrote about a book called How to Cool the Planet that Kelly mentioned that was about climate intervention. And I was just reflecting today about how that started. And it was in 2006, I met this big heavy guy with a red beard who was driving around Silicon Valley in a beat up car. And his name was Lowell Wood. And he was a disciple of Edward Teller, the famous architect of Star Wars and of hydrogen nuclear bomb fame. And I wrote a profile of Lowell, who was a big advocate of climate intervention. And at that time, this was almost now 20 years ago, he would lean across the table when we were having pizza together. He loved pizza. And said, Jeff, we're going to do this. It's fast, it's cheap, and most importantly, messing with our environment is what humans do. And I dismissed that, and I thought, I don't, you know, I brought up all the problems and questioned all of that. But now when I reflect back on this now 20 years almost later, I'm not sure that he was wrong. And in the 20 years or so since then, on one level it seems like not much has changed, and on another level a lot has changed. We have record-breaking heat that Kelly mentioned. We have more and more climate impacts. We have, I guess, just the other day, 2024 was is the hottest year on record. We have sessions at AGU yesterday about is this heat a consequence of ship aerosols? Is it because of we're moving into a new climate regime? What is really going on with our atmosphere? The sort of urgency of this question about climate intervention has never been greater. And then you overlay that with the changing politics. I don't really need to go into detail. I'm sure all you know, I mean, have thought about plenty. And it becomes a very urgent and very compelling thing to be thinking about, talking about, and researching. So with that, I want to introduce the panel. So to my left here is Anna Burstein, Associate Professor, Department of Population Health and Director of Project Heatwave at NYU Langdon Health. We have Alex Azan, clinician and Assistant Professor, NYU Grossman School of Medicine, and Jean-Francois Lamarck, the Chief Scientist at SilverLining. So, Anna, let's start with you. We were just talking, you work on many things in the public health realm. Tell us about how and why you got interested in thinking about heat and the consequences of heat, and how that led you to Project Heatwave.
Sure, thanks for the question, Jeff. I do, with a group at NYU, work on many things, predominantly pandemics and HIV/AIDS. And I work in a department of decision sciences. So much of what we do is partner with implementers, decision makers, normative agencies that are facing some crisis, and help to advise about how do you provide the most health to the population with the limited resources that you may have, as well as how you prevent disparities from growing and maybe even shrink disparities. And so we've done that, for instance, in a small country called Eswatini in southern Africa, which has the highest prevalence of HIV in the world, 27%. We've been working with that country on what is the best HIV program given the very limited dollars available as well as the limited number of doctors, right? Brain drain is very real in these settings to combat HIV. And then lately, what's the best health system to build in general? What services should be provided by the health system, like hypertension care, cancer screening, all of these things. With the limited resources, you can't do everything. So what can you do? And I have to say, I'm relatively optimistic about many things in health. For example, in my field of HIV, just this year, an injection twice a year was found to be 100% effective at preventing HIV. And I really feel optimistic, so much so that I think the world has multiple labs like mine, like my lab at NYU, doing these kinds of analyses. And I don't know if a lab like mine focused on HIV is going to be needed in a decade. At the same time, I've been following climate somewhat distantly, and I've always, like everyone I would say in this room, had this awareness that the two biggest health effects of climate will be malnutrition and starvation from crop failures and extreme heat, and that those will be borne very inequitably. And I started to wonder, well, who's doing the same work that I do on pandemics, but for extreme heat? Who's telling mayors and normative agencies, how do you spend your limited dollars to reduce mortality? And I couldn't find anyone doing that. And that's a scary realization. So that was really what created the pivot for me, was how do we apply these methods that in other parts of global health are pretty familiar to this area of extreme heat that it's not news. And so it's quite surprising that this isn't an area that's already quite active. I think that scientists are behind, scientists like me, donors are behind, governments are behind where we need to be in order to reduce mortality.
Thanks. Have a new mic. Is that working? Maybe we should go back to the old mic. Okay. So Alex, let me ask you about one of the things that I was reporting in my book about heat and thinking about heat is thinking about, there's a lot of talk about heat mortality, and this is something that is, as Anna mentioned, is one of the most extreme consequences of a hotter world is that, living things die. Heat is a killer. And in my book, I call heat a predatory force that goes after the most vulnerable first. And I think, but I think that it's worth hearing from you a little bit about, like, what does heat do to the human body? Why is heat so dangerous?
Thanks for that question, Jeff. We've learned a lot about how heat impacts the human body, primarily through thermophysiology and researchers who are leading that field. I think you mentioned this very clearly in your book, Jeff. The main reason why heat is so dangerous to human health is that it's an invisible threat. The human body doesn't recognize that it's in danger until often it's too late after being exposed to heat for a long period of time. The reason why that is at a very basic level, what happens physiologically when you're exposed to heat is your body tries to cool itself through various mechanisms. One of the primary mechanisms that the body uses to cool itself is through evaporative cooling with sweat production. And so our peripheral vascular system vasodilates, which allows our heart to pump blood that's warming when our core body temperature is warming. And when more heated blood reaches our periphery, we're able to activate our sweat glands and cool our bodies through producing heat and producing sweat and evaporating heat through that way. The reason why heat is so dangerous is, there's multiple factors to consider. One is how efficient is that cooling mechanism across different segments of the population. Older adults are not able to produce sweat as efficiently as younger adults and children, and for that reason aren't able to cool themselves through evaporative cooling in that way as efficiently. And in addition to that, older adults and even adults who are middle-aged have increasing prevalences of chronic health conditions and multiple chronic health conditions that make it hard for the human body to compensate for that increase in cardiovascular strain that's needed to pump that heated blood to your periphery. So those are two primary reasons why how heat affects the human body and how that leads to poor health outcomes. The way that heat ultimately harms us and oftentimes can lead to death is that when your body isn't able to cool itself efficiently and meet the demand on your cardiovascular system to cool itself, people go into what we call circulatory collapse, which can lead to shock, which is a sort of end result of heat stroke, and it leads people to unfortunately pass away. Another factor to consider is our growing understanding of how different exposures, different heat exposures impact that thermophysiological mechanism of cooling in the human body. We're learning more and more about how humid heat is something that is consistently demonstrated in the lab to reduce the human body's ability to cool itself, meaning that it reduces the sort of survivable threshold that human bodies have when exposed to extreme heat. The reason for that is in order for our sweat to evaporate, there needs to be the atmosphere around our bodies can't be too humid in order for that mechanism to occur. And so with more and more humid heat waves, we're seeing that people are not able to evaporatively cool as efficiently for that reason as well. So those are some of the reasons why.
Well, that's a good point. I mean, one of the things that I learned that I thought was really important in my reporting the book is that all heat is not equal, right? Dry heat is very different than wet heat, right? And because of what you mentioned, the ability to evaporate off, moisture off your perspiration, off your skin and things. So when we think about, that's why there's all these different kinds of measurements, right? Of heat, like wet bulb globe and things like that, right? Those are really important to make these distinctions in something that we're just sort of learning more and more about. Greg, I want to go to you. You came in a moment late. I want to introduce you. This is Greg Pulley, head of the Climate Team, UN Office of Coordination and Humanitarian Affairs. So Kelly mentioned data gaps. I guess you weren't quite here yet. You were running through the rain. But she mentioned data gaps in our understanding of heat. And it's something that I came across very obviously in my book. When you think about heat mortality, and when we think about what is the real human consequences of heat, there's not only problems with how we die, when we look at mortality numbers, as I write in the book, that heat is not like a gunshot. You don't get, there's not an easy, when someone dies, you don't look at them and say, oh, this person died because of extreme heat, right? That's often shows up as a heart attack or many other things. But there's also a broader data gap just in, when you think about this as an impact for the world, in countries that don't have good public health systems and that don't have, even in the US, that would have, in theory, a pretty good public health system, we're really bad at it. But I'm interested from your perspective, given your sort of global look, and how you think about what we know about heat mortality around the world.
As you say, their death is often recorded or attributed to a secondary cause. But then also because geographically across different regions, there are huge disparities in terms of data collection. Africa, for example, we know is a place where temperatures are rising faster than other parts of the world, where extreme events are happening more frequently at a pace that's greater than other parts of the world. And yet there are very few extreme heat-related deaths recorded in Africa. To do both with the first phenomenon, but also with just the general gaps in terms of health systems and data collection. So we do have a big challenge to face there in terms of raising awareness about the health-related consequences of extreme heat, but then also in helping lower-income countries, developing countries, where we know there will be an outsized impact. There is already an outsized impact of extreme heat and other climate hazards in lower-income countries, to fill those data gaps and to build the monitoring systems necessary to help both determine the scale of existing impact of extreme heat, but then also critically to help to improve the systems to forecast and enable societies to prepare and act early in the face of impending extreme heat events.
Yeah, one of the things that I've been struck with since my book came out, and just since I sort of finished reporting, is, you know, how much more we're learning about the impacts of heat, and it's striking the degree of ignorance that we have had about the impacts, not just of mortality in countries that don't have the capacity to, you know, basically count the bodies, but also just on labor, productivity, on all kinds of things, diseases. You know, it just this. Heat is like this sort of emerging, like, iceberg that's coming up out of the sea, which we're just beginning to see the full, not even close to the full kind of consequences of it. So, Jean-Francois, let me ask you about this. This is because this also goes to how we understand and predict and think about what our future looks like with heat waves. I mean, we talk a lot about, you know, climate scenarios, 1.5, 2.5, whatever the numbers are. But these are just average, you know, global temperatures. You know, one of the most important, I think, and a kind of dramatic examples of the dangers and risks of heat is what happened in the Pacific Northwest in 2021, where you had this heat wave that came out of nowhere, and you had temperatures that were 25 degrees or so higher, and everybody was unprepared, and a lot of people died. And when we think about what Greg is talking about, it brings up this question of, okay, so I was joking earlier, is when we were talking just before this, are these heat waves like trucks that you just step out in the street, all of a sudden you're hit with a truck and you don't even see it coming? Give us a sense of the sort of state-of-the-art science, as far as you know, about how we can predict and see these heat waves, and what we know about detection of them.
So, thank you. Can you hear me? So there are lots of elements to the question you just posed. Great question, and lots of elements. So I can think of heat waves as like a superposition of a very localized warming spot over an overall background. So we have the global temperature rising, and Kelly was showing that figure, and so we can think of regionally or on a smaller scale the appearance of a heat wave. And so it's like that combined effect of the fact that we've had heat waves are part of the natural system. They're getting worse, in part because the baseline, especially regionally, can be much higher than the global amount. One big aspect related to what Alex was talking about is that the atmosphere holds more moisture just because it is warmer. So the overall humidity in the system will be warmer. So in terms of what you're asking about the predictability, this is some of those events, like the Pacific Northwest one, was kind of like a perfect storm. So perfect storms are always going to be extremely hard to predict because they require basically everything to line up perfectly. We do understand, if we can measure, if we have a full understanding of what the system is, then we'll be able to project and do the forecast, mostly on a few weeks, but that might be enough to really help forecast. So in the longer term, we are facing issues that those are extremes, and by definition, extremes don't appear very often. So we're left with trying to identify, out of the many different scenarios and many different days and many different models that we have, where are those very extreme events going to happen? I think part of what we're seeing is that some of the ways we have been looking at those projections is actually not sufficient. We've been looking at averaging well, we should be looking at single events, right? It's 1 in 1,000 years, 1 in 100 years, something like that. So really going back to what is an extreme and trying to pull those extremes out of the big haystack. There's going to be a needle there, but the needle is there. It is just trying to identify what is the potential risk associated with such a needle to appear within a certain time.
So I want to follow up with one question on this because it's such a topic right now. So I'm interested in your views on this basic question right now of, we've had a decade of the hottest years. We had 2020, 2024 is now the hottest. There's this question of is this because of aerosols getting cleaned up because of low sulfur ship fuels, or China cleaning up coal plants, or is it because of this new climate regime? I know this is not your area of particular expertise, and I'm putting you on the spot a little bit, but how do you think about that?
So,
in other words, let me put it another way. How freaked out are you?
well, and actually, it's kind of my area of expertise. But
okay, sorry.
but the
Really freaked out.
yeah. Well, so it's probably pretty much everything you mentioned are going to play a role. So but again, it's part of an overall system that moves, and then we add forcings, what we end up calling forcings, which is basically a change in the amount of radiation that hits the surface. And one can think of different ways to have that. Aerosols are fairly reflective, depending on the aerosols, but mostly on average they are reflective. If you remove them, you expose more of the surface to the sun, and the surface is darker, so it will absorb heat. And so we can actually measure that fairly well from satellite. We have enough satellite measurements we can start establishing what has been the influence over the last few years. It's a lot harder to translate that into a temperature response because underneath there is still, are we in an El Nino year? Are we going into an La Nina year? Are we warming up? So there are all those modes of variability that are really difficult to understand because we don't have enough observations throughout, especially over the ocean or in the ocean. So we don't have a full understanding of where we are, on top of which we are adding this.
Right. Okay. So you still didn't answer. How freaked out are you?
Very.
Okay, me too. So Anna, I want to talk about interventions from a human point of view. And I want to talk about how bad we are at that. And I've mentioned this before, I think, and I was on CNN this summer during a heat wave having a discussion about, similar to this discussion, and the head of the emergency department at a major New York hospital, whose name I will not mention, the CNN anchor asked us at the end, what are the 2 or 3 things that that we can do, that people who are listening can do during a heat wave to protect themselves? And the number one thing, first thing he mentioned, number 1 was sunscreen, which is like irrelevant to heat exposure, right? And to me, it was emblematic of how little we know about interventions, about how to protect ourselves, and that's going to be the subject of this conversation, in the second half of the panel in a larger scale. But I'm interested in how you think about it from your very human point of view. When you think about interventions, what do you think about?
No, absolutely, and I think when we think about interventions, we have to think about what the impacts will be, but also what resources are available. And ultimately, in this kind of policy analytics domain, it's about the optimal allocation of resources across the choice set of things that we can do that will save the most lives. And let's just name it, there are not enough resources, right, to combat extreme heat. And the places that are going to be hit the hardest, the soonest, have nowhere near the resources necessary. The setting that with Project Heatwave we think about a lot is Bangladesh. So the coast of the Persian Gulf and then Bangladesh are 2 places where the climate forecasts show that conditions are going to soonest become just unsurvivable to humans. You can put an athlete, a soldier, a very fit person in a heat chamber, and those are the conditions with which nobody can keep their core temperature under control. Everyone goes into heat stroke. In fact, some of those temperatures have already been recorded by weather stations along the coast of the Persian Gulf, fortunately in areas that, due to burning oil, due to them being oil-rich states, have a lot of air conditioning and are able to keep their populations alive. But you think about Bangladesh, the site of the world's largest refugee camp, a country that's also going to be hit by coastal flooding, very flat and at sea level. And what is the choice set for these settings? It's really not much. Building a cooling shelter is going to cost money that's not available. It's going to rely on a grid that's not reliable. Distributing air conditioning. It's not a pretty picture, even if you optimize the use of the very few resources available. And that is really what pushes our project, where we're trying to advise stakeholders into the domain of innovation. Maybe we should be plowing those resources into making tools that don't exist today, because it's such a grim picture today. And we think of those tools in 3 categories. On the biomedical side, Alex described how our body responds to heat, and actually there are a number of medications that are known to worsen that process. The so-called anti-medications, SSRIs, which are a type of antidepressant, antipsychotics, and a type of antihypertensive called a diuretic. Very, very common medications, many in the room may be on them, actually increase the risk of going into heat stroke. But what medications decrease that risk? We don't know. We know that once someone is in heat stroke, there are certain things that can be done to prevent seizures. You can put ice packs on them. There's some experimentation with ways to reduce organ failure with clotting and all of these things. But what is, in a radiation emergency, we pass out potassium iodide to reduce, the risk of thyroid cancer. What do we give a population in a heat emergency where they can't access air conditioning? That's an area that just has not been studied. A second area is on the engineering innovations, right? What is FEMA in the US or the Red Cross going to come in with, where there's a deadly heat wave in a situation where it's too many people to evacuate, it's impractical, and there's no infrastructure to cool those people? How will we do the pop-up cooling tents, or can we pump a local water source that's going to stay a little bit cooler to where the people are? What are we going to do? There's just nothing in the arsenal. And then the third one, the big one, is climate interventions, right? For all of the uncertainties and the risks, suddenly it makes a lot of sense when you think about a setting like Bangladesh, where there just is nothing in the current arsenal of interventions.
That's great. So I want to get 2 more quick responses. That leads us. I want to ask Greg you about this, but first, Alex, I want to ask you about this. So the next part of our conversation is we're going to move to more discussion about interventions and questions about albedo and reflectivity and things like that. And I know that you are very interested in this from a sort of more, say, down-to-earth point of view, which I think is also really important and one of those things that is sort of a no-brainer. So tell us about white roofs.
Yeah, thanks, Jeff. It seems random, but in my training as a primary care physician, I strongly believe in prevention and trying to decentralize healthcare and preventative efforts as much as we can. And increasingly so in clinical medicine, we know about the importance and sometimes the greater importance of structural and intermediary drivers of health outcomes in our built environment, green space, for example. And so as it relates to trying to understand interventions that are more intermediary, that can be done to protect and prevent heat health outcomes in areas like New York City, which is primarily urban. One interest that I've had, and I'm doing research now with in partnership with the mayor's office there in the Department of Health, is trying to push the research further that has demonstrated the benefits of roofing interventions like cool roofs, which are high albedo roof surfaces I'm sure many in the room are familiar with. They're either cover or replace darker colored low albedo roof surfaces that contribute to reflective cooling in New York City primarily. There's been a lot of research that has shown at the city level how those roofing interventions cool cities at the city level. And there's been more research looking at the impacts and benefits of those interventions on the infrastructure itself. So, the roof cover lifespan, HVAC unit lifespan, and sort of energy consumption metrics within the household. But no one has really used observational data to understand the impacts of those interventions on health at a more granular level, at the person level even. And so in cities like New York, we are privileged to have access to administrative and increasingly so electronic health record data, where we can try to understand what are the potential heat health benefits of interventions that have been shown to mitigate the urban heat island effect, with the example of cool roofs. And so when we think about interventions that are generalizable to different populations and scalable to different urban environments, I have a particular interest in cool roofs. There's a lot of talk around green infrastructure, which is incredibly important. But as it relates to roofs, comparing green roofs to cool roofs tend to be more feasible and scalable than green roofs. And so I think in parallel with pushing green infrastructure interventions forward, in my research, I try and highlight the potential heat health benefits of these more feasible and scalable interventions like cool roofs.
All right, that's really great and important and simple. Greg, I want you to take up on what Anna was saying about Bangladesh. What do you do? You're thinking about this from a global point of view. You're thinking about this in the developing world. What are the kinds of interventions that you're thinking about in situations like what Anna was describing?
Well, Jeff, I think the starting point for that is the observation you made earlier that it's a predatory force that pushes the most vulnerable people to the front lines. So I think the first element of any successful strategy for responding to that is understanding who the most vulnerable people are. The elderly, pregnant and breastfeeding women, occupational vulnerabilities that people have, people who live in neighborhoods, poorer neighborhoods, which by the way are much hotter. It's not just that they don't have access to the services, the temperatures are actually much higher in informal settlements, for example, as they are in refugee camps. And so starting with understanding what the potential impact of a heat wave will be on the most vulnerable people is at least one way to begin to think about interventions that are more targeted. And then without wanting to overstate it, of course, I agree with the general point that there are hard limits to what you can do, particularly as you start approaching the physiological limits of what the human body can endure. But there are public policy interventions in terms of changing working hours, where social protection systems exist that are able to support people. You can have an adaptive approach where they expand during a time of crisis. Reinforcing the health system, providing more clean, cool water. I've just lost the other point I was going to, the cooling centers. Acting early and at least providing early warning, if at all possible, beginning these interventions before the onset of the disaster. We're beginning to work more in an anticipatory way in the humanitarian system, where we're using forecasts to activate pre-agreed plans before the event. That can have significant benefits. I was in Pakistan earlier this year, where there are these anticipatory action approaches in place for heat waves. Obviously, extreme heat's a huge issue there, as it is in Bangladesh. So there are things that can be done from an emergency response perspective, even in a relatively low resource setting, that can have some impacts without wanting to overstate that or pretend that that's the solution. The longer term adaptation and of course mitigating climate change, those are the real solutions. But we've seen some success in heat health action plans in a country like India, for example, where over 100 cities have these plans. They have been shown to reduce mortality. IPCC reflected that in its comprehensive study. So we can do more of that. And we can support local emergency responses to extreme heat. So there are some interventions that can be effective, but comprehensively, it's going to be very difficult to deal with the levels of mortality and morbidity that the future portends.
Well, that's a good place to wrap this up. Thank you very much, all of you. We are going to take a little break and watch a little movie, a little short video, and then we will be back with the second panel.